Okay, I'm gonna go over a basic rundown of how this lab is conducted and what you can do to kind of adjust for your class. So we have 5 stations here, and I'll go over each of those stations, and this is a handout the students get. So the handout is really just for students to gather information, and the stations is what tells the students what they have to do. So in this first station here, essentially kids are just picking any 3 cubes. They're measuring the volume using a ruler. So every station is pretty much gonna have a ruler, and then they would find the mass either using a triple beam scale. I have triple beam scale, but you can use a digital scale. That's really up to whatever resources you have. As for the document's editable, so you can edit it to digital scale or triple beam scale. Okay, that's first station. That's just kind of getting them familiar with density. Second station here, very similar. They're finding the density of a wood cube and the density of a metal cube. And I'll go over kind of why I'm doing this in stations as well, but it's really due to limited resources. If you don't have a bunch of density sets, you can get away with just using 1 or 2 density sets. So you can use any metal, really doesn't matter. Also in these here, I tend to put the name under so kids know how to put them back in the correct location. But I left those blank because it just depends on which ones you're going to use. So here, they same thing, density, they find the mass, volume, find the density, then they put this in water and they put this in water, and they should see that things with a density lower than 1 are floating, things they're greater than 1 are sinking. So that's really the purpose behind that. This one, again, mass can be found using the triple beam or a digital scale. Then you use a ruler to find the volume here. The kids aren't super familiar with the volume, so I give them the formulas. It's really more of an explore activity. They don't have to know every single detail about how to calculate volume, so you can kind of just guide them through that one. So this kind of purpose behind this station is for them to realize that the shape does not affect the density. Different shapes will, as long as they're the same material, should have the same density. So here I have these acrylic shapes. If you don't have this, you can kind of get creative. You can use wood, right? So pieces of wood, 2 pieces of wood that have very similar density. So a square piece of wood, a triangle piece of wood. Or you can go to Michael's and get like styrofoam, and you can have a triangle styrofoam and a rectangle styrofoam. That'll work as well. So as long as it's the same material, just different shapes. This station here, students are essentially getting used to using the water displacement method. We have it's not necessarily an irregular shaped object, but it is something that's difficult to find the volume. So they would use a graduated cylinder, and they would use a scale, either a triple beam or digital, to find the mass, and they would put that in there and do that. If you don't have something like this, you can just get creative and use any type of irregular shaped objects. I used to use glue sticks. I would just cut them up into different shapes, and they would kind of just find the volume of that using the water displacement method. Then the last one, this is the station that varies between the easy format and the difficult format. For the easy format, I think that station, they're just going to work on calculating volume for different objects. So you can just pick 3 objects, they calculate volume. This here is the difficult version. What they are doing here is they are finding the thickness of a piece of aluminum. How do they do that? They have to basically find the mass of this aluminum. They then have to find with the mass. I give them the density. So they have the mass, they have the density. They can now find the volume. Now that they have the volume of this, they can find the length, the width, and using the length and the width and the volume, they should be able to solve for height, which is the thickness of the aluminum foil. That could be a little bit difficult. This is folded up because I tell them to fold it up when they put it on the scale to make sure we're getting the full mass of that on the scale. And that's pretty much it. I do have all 5 close, but obviously when I'm doing the actual lab, they're spread out. And what I tend to do to make groups smaller, I duplicate the stations. So I go 1, 2, 3, 4, 5, and then on the other side of the room, I would have another 1, 2, 3, 4, 5, and just kind of replicate them. So there'll be 10 stations in total, but 5 would be the same. Or yeah, 5 of them were the same. that just helps makes groups a little bit smaller. And you can do their own pace. I like to time it. It's really up to how you want to structure that, or you can just have them. I usually tend to time it and have them rotate clockwise. Eventually they get to every station. That's really up to you.